All right, so today we're going to talk about applications of exponential functions. But before we begin, I want you to remember what an exponent means. It means you're taking some number times what? Itself over and over and over again, right? So like 3 times 3 times 3 times 3, right? Don't forget what an exponent actually means, right? So we also want to talk about a few keywords that they like to use. If you're doubling something, what does double mean using multiplication? Times 2, right? Okay. If you're going to triple something, what does that mean?
Times by 3.
There you go. Right? So a few keywords that you're going to see a lot in these applications. Okay. If I have twice as many, that's doubling, right? Times 2. So keep those ideas in mind as well. And then we're going to go to the book and look at some examples. Okay? So keep in mind, exponent simply means the same number multiplied times itself over and over again, right? And doubling and tripling, those two ideas are really important for us. So let's just look at some of these. The first one is pretty straightforward. They're just going to give you a table of values. You're going to plug in the values and then work it out. So we want to do this one, though, because you need to remember what all those different exponents do. Okay? So your equation is y equals... Oh, sorry. So y equals 3 to the n, I'm sorry. 3 to the nth power. And they give you some values they want you to use for n. You're simply going to plug those values in and do the math, which is no big deal. But I just wanted to do this one there's no thought about what you need to do, but I just wanted to remind you about what happens with exponents, right? So the first one is negative 1. So y equals 3 to the negative 1. What does a negative exponent tell you? That it's on the wrong side of the fraction bar. It shouldn't be 3. 3 should be underneath the fraction, right? Underneath the fraction bar. So that means takes it down. And if the 3 moves down, that makes your exponent positive. And then it leaves a 1 up top because you always have to have something in the top of a fraction, right? So, yes, you'll have a calculator, so you could just plug that in. Okay? But it's faster if you just memorize it, right? You can just write it down. But it doesn't matter. How you get there is not the thing I'm looking at. Y equals 3 to the 0 power. What is anything to the 0 power? 1. So those are the only two oddballs. And then you're just going to do 3 to the power. So y equals 3 to the first is 3. 3 to the second is
9.
3 to the third is... Yeah, after that point, well, even before, if you get 1/3, 1/3 times 3 is 1, times 3 is 3, times 3 is 9, times 3 is 27, right? Because you're don't forget what an exponent means. So once you have 1, as long as the numbers are in order, like these are, if they jump around, you'd have to actually do it. But if they're in order, you can just multiply the previous answer by 3 to get the next answer, right? But be careful if you're going to do that, because these numbers would have to be in order for that to happen. It's just, I don't know.
So n is the...
Yeah, n is your x value. Mm-hmm. But you know it's your x value because it's the first column, right? Yeah, I agree. Okay, so now what we want to do is we want to graph those, right? So negative 1, it's 1/3. So go to the left 1 and up a tiny bit. For 1, it's 0. So there it is. We knew it was going to go through 1, 0. Can anybody remember why?
Wait, wouldn't it be in between because it's a 2 unit thing?
Oh, are they counting in 2s? I can't see.
Yeah.
Oh, and this is also counting in 10s, isn't it? Ugh, what a horrible graph.
Yeah.
Okay. So 2, 1/3. So around there somewhere, maybe? So is it 2, 4, 6, 8, 1? Oh, these are across the x-axis is 1s? Okay. I've got mine too far down, so I can't see, but I don't want to move it because... So 1, 1/3, so it's very tiny since they're counting in 2s on the way up. 0, 1 is right there. Okay. Really hard to do with these. That's a terrible scale. But I knew it was going to go through 0, 1. Can anybody tell me why I knew it was going through 0, 1?
Because it said 0.
Before I even filled that out, I knew it was going through 0, 1.
Because when you times one above it's to the power.
Well, just look at the equation.
When something's to the power of 0 equals anything.
Yeah, so if you have no plus b or minus or plus or minus c, if you don't have any of those numbers on there, it's going through 0, 1. Every exponential goes through 0, 1 there. Okay? All right, remember that? And you're exactly right for your reasoning, because anything to the 0 power is always going to give you 1. All right? So always going to go through 0, 1. Remember, we were using that to be able to write the equation of other things that didn't go through 0, 1. Okay? So then 1, 3. So about there. 2, 9. So 2, 9. 3, 27. So 3. What is it? 28. So 27. Every single one of them was between two lines. That's nice of them. Okay? And then you draw your line. Now remember, don't stop at the points. Continue your graph all the way through from edge to edge. If you don't, you haven't drawn the graph. If you draw this, you're wrong.
You have to get it.
It has to continue infinitely in both directions, which means it has to touch the outsides of the graph, the edges of the graph, right? Now, you could draw the other way I did if you put arrows at both ends, but I wouldn't take my chances with external graders. Or I wouldn't take chances, period. Just go from edge to edge. All right? That's all there is to it. Okay.
Not if you get like super close to the asymptote.
Yeah, no. Just get as close as you can. Everybody knows that it's really hard to draw. Okay. Right. For that one, what are the coordinates for the y-intercept?
1.
Yeah, it's 0, 1. It's the y-intercept is at 0, 1. So coordinates mean the whole point, right? If they just say y-intercept, then they mean just the number. But if they say coordinates, they want the x and the y. Okay? So 0, 1. Use your graph to find the approximate solution to 3n equals 20. So all they've done is reverse it. So my y value is that they want me to find is what? 20. So you just go across. Oops, sorry. Keep doing that. Keep forgetting to push my button. So you just go across to 20 until you hit the line. Now my line disappeared because I had to scroll down. But if you have it on your paper, you can see. So what value does that give you? About?
2.8 or something?
2.8, I don't know, somewhere in there. Somewhere between 2 and 3, a little closer to 3, right? By just looking at your graph. So just go across. Now, they're messing with you here because they reverse that, so be careful, right? Instead of the y equals the function, they just they reversed it, but it means the same thing. So that's your y value, okay? All right? So n is approximately, what, 2.8-ish? 2.7-ish. Okay. All right. Good job. Okay. All right. Question 2. So this one's a straight out word problem. In an Indian legend, a wise man called a king to a game of chess. The king was so rich he offered the wise man anything he wished for if he won. The wise man asked for 1 grain of rice to be placed on the square of the chessboard each day, and then double the number of grains were to be placed on the next square, and so on, for all the squares of a board. And there are 64 squares on a chessboard. Okay? He agreed to it, and then the wise man won, so he had to do it. But he couldn't. It's impossible. Okay? And we're going to find out why. Calculate the number of grains of rice that we place on the 64th square. Okay? So each time, you're doubling what you had before. Do you agree? So we start off with how many grains of rice?
1.
Then we're going to double it the next day. So that's times what?
2.
Then we're going to double it the next day, which is times what?
2.
Double it the next day, which is times what?
2.
And then the next day.
2.
Blah, 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 blah. Right? How many squares are there?
64.
So does that make 2 to the 64?
Yes. Wouldn't it be 2 to the 63?
Why 63?
Because the first one's
There you go. He put 1 grain on the first one. And multiplying by 1, do we even care about that 1? No. So it's 2 to the 63rd. Okay? And they tell you this in the back, but this is a classic problem. If you have 2 to the 63rd grains of rice, that's enough rice to cover the entire country of India with rice. Deeply. Isn't that amazing? That's the power of exponential growth. What is it? I've forgotten. Oh, no. Cover the entire country of India to a depth of 1 meter. So, that much rice over the entire country of India. India is huge. So that tells you the power of exponential growth. It's amazing.
I put on my calculator and
It can't do it.
It's like E plus 8 or something.
Yeah, it gives you exponential back. It gives it to you in scientific notation, which y'all call, what do y'all call it?
9 point that.
Standard form? Yeah, that weirds me out. You move the decimal, right? So what does it give you? What does it give you in standard form?
9.22337 E plus 18.
What now?
E plus 18.
Okay, so that means times 10 to the 18th power. So that means multiply by 10 18 times. So that just means move the decimal to make this number bigger 18 decimal places.
Oh my god. Wow.
That's a lot. Right? It's beyond billions, it's beyond trillions. It's whatever comes after trillions, I never remember.
And then technically would we have to add 1 after 2?
No, because it's multiply to double. Okay? All right. Let's keep going. Yeah, you would think you would have to add that 1 back in, but yeah, if you got the number, after you got the number, if you were actually counting them, yes, I agree with you. I'm sorry. You would need to add the number, that 1 back in. It's the only one you'd have to. Yeah, I don't think that 1 grain of rice is going to make that much difference, but yeah, you'd have to add it back in. Okay? All right. Now, guys, they love this kind of thing. You've seen this before probably in another class too. A bacterial colony covers 5 square millimeters on day 0. Its area doubles each day. Complete the table below to show the area it covers on the following days. So that's pretty straightforward if it's doubling. So what's it doing? If 10 doubles, you get then... Oh, I'm only counting in tens. Apparently, I should go home. All right, 40, 80. Okay. Sometimes I really worry about me. But I don't care, so it's all right. Okay. So, the area on day whatever, okay, can be found by thinking about this as doubling, which means exponential growth, right? You have 5 times 2 times 2 times 2 times 2, whatever, right? So what day would this be if it's 5 times 1, 2, 3, 4, 5 twos? So this is 5, then 1, 2, 3, 4, 5. Yeah, so each time you get that 1 more 2, times 2 again. So the area on day 5 would be 5 times 2 to the what power? How many 2s do I have?
5.
So 2 to the 5th. Right? Which then they want you to work it out and get a number. And I don't have a calculator, so I'm not doing that. All right?
160.
Thank you. Okay? So, again, think of doubling as multiply times 2 over and over and over and over again. Make sure you do that. Use the pattern B to help you write an equation for this relationship. All right? So we're going to write a pattern for it. In other words, an equation that looks like the ones we had before. The area that's being covered is equal to, what's the base of our power? P. So our P is 2, right? In this particular instance. Right? So you're exactly right. What we're doing is we're writing that. P to the x plus or minus B plus or minus C. So 2 to the what power? In just a general form, n or x or whatever. We don't have anything added to it or subtracted from it. And they're using n, so I used... no, they're using d, so actually d. I'm sorry. So 2 to the d. And if you put x, they're not going to count that wrong, right? All right. Now, was there anything added or subtracted? You got that first day. It has to be 5. Remember how to do these? If you replace that with 0, find that 0 value, that's always the one you're adding to.
Would that be like C?
So yeah, that would be your C.
Why didn't we do that on like when we did B? We didn't know 5.
It's there. You have your 5 in there. Your 5 is extra in the formula,
Yeah.
right? Because the 5 is where you started. It wasn't doubled, was it? On day 2, the 5 was you got 10, which is double 5. But we never. But on the first day, that thing wasn't. Whatever number you had on the first day was just the number. It didn't have it. It wasn't doubled. Okay. Yeah. These take a little thought. All right. But again, remember these are going to be your excellence questions too. Then you plot the values on the graph below. Then you use a graph to estimate some value just by. So if it's 50, you'll just go up to y equals 50 and find out where it's crossing the line. Yeah?
You just plug it in and
Well, you don't even have to plug. Yeah, you just find it here and you find an approximation. You're going to estimate. So they don't even want you to plug it in. They just want you to. You could plug it in place. You could put it in place of A and work it out algebraically, but that'd be much harder. Just read it. So if we plotted this, for example, let's just say for kicks that it looks like this. We just go here to 50 and go across and then go down and read that value. Just like you did the 2.7 or whatever ago. Same thing. I guarantee you're going to have to use that skill. Okay? That's one of the reasons we do exponentials. What is the area of the colony the day before day 0? Okay. Well, if it's doubling every day.
2 times -1. 2 to the power.
Yeah, so it's right here where it's -1 is the day before 0, right? So you just need to read this value from your chart, from your graph. Now, I think it would be easier to do it from thinking about if it's doubling every day, what's half of 5? 2.5, right? So 2.5.
Okay.
It's doubling every single day, so if you go backwards, you have to assume that the pattern still holds, right? Does that make sense? It's a thinking question. But then when you see it, you're like, oh, duh. Right? Okay? All right, so you're going to have to draw some graphs, read some things from graphs, and then find the equations. So what I'm going to do is I'm going to let you work on the rest of these. There aren't many more, are there? All right, that was 3. Oh, we didn't say, describe what would stay the same on the graph and what would change if it tripled. What's the thing that would stay the same for sure if it tripled?
The first day, the 5. Like, where it stops.
Yeah, the 5. Mm-hmm. So that would stay at 5 because it says day 0, and 0 to any power doesn't matter. So the 5 part of that's going to stay. What would change? What would change?
The steepness.
Exactly. It would be much steeper, right? So that stuff would cover that water much faster. Okay?
Can equal steepness.
Well, gradient would be very steep, yeah. So you can call that. The gradient would increase significantly. How's that? Okay? Right? So just think about what it would do to the graph. Okay? Would it change what's happening at the bottom? Not really. What happens when you get toward the asymptote? On the negative side, it still gets slow. So it really doesn't matter if it's a 2 or a 3 on the asymptote side, on the other side of the thing getting near the asymptote. Okay? Describing that. So that would be an excellence question, that one we just did. Pretty straightforward. But you need to practice some. So, we have some practice. Oh, we have one practice. One! They don't think these are very important, I guess. So, do number 4. Okay? And just to make sure that you can get those running.